dear student. We are in the series of quantum technology and we are discussing the quantum algorithm. Welcome in the CEC-UGC lecture, and we will discuss the various quantum algorithm that are used in the quantum technology. It may be used in the quantum computing, quantum computation, quantum materials and others where we can use these quantum algorithm. So, we discuss the four main quantum algorithm. We will discuss one by one. First, we discuss the Shor algorithm. Last time we also discussed about the brief idea of the Shor algorithm. Now, we will discuss in the detail. Now, this is the Shor algorithm stands as a monumental achievement in the quantum computing, renowned for the unprecedented capabilities to factor large numbers exponentially faster than any classical algorithm. So, we discussed that we use the Shor algorithm for the factorization of the large number of the polynomial equation as well as the exponentially. It will make the factorization faster and the processing of the large data may be done efficiently in a very less time. So, Shor algorithm is a quantum leap in a number factoring. So, it is a capability to factor the large number exponentially faster than any other classical algorithm. So, this quantum algorithm not only signifies a breakthrough in the computational speed and efficiency, but also has profound implications for the field of cryptography. As I discussed that it is used for the quantum computing and for the other applications. So, it is one of the application that is the field of cryptography where we use this quantum algorithm, that is the Shor algorithm. Now, this is challenging the security foundations of many contemporary encryption systems. So, basically we use Shor, we just factorize the data and then we use this data for the encryption. So, what is the history behind this? So, a history breakthrough in the quantum computing. So, Shor algorithm introduced by the mathematician Peter Shor in 1994 marked a revolution in the field of quantum computing, and this algorithm is just used in the quantum computation. So, this algorithm did not just demonstrate a practical use of the quantum mechanics, but in the computational task it fundamentally challenged the existing cryptographic protocols based on difficulty of factoring large numbers. As in the encryption and description and in the cryptography we have a large number of data. So, just to make the efficient use of these data, we will use this Shor algorithm for factoring the large number of data. Now, before the advent of the quantum algorithm like Shor, cryptographic systems such as RSA encryption relied on the assumption that factoring large number is computationally intensive for the classical computing. So, we use this Shor algorithm for a large number of data, and moreover we are ensuring the security of the communication channel. All these must be followed by the algorithm, means we factorizing the data as well as we secure that data. So, Shor emerged a crucial juncture when quantum computing was transitioning from theoretical exploration to the practical application. So, whenever we define it theoretically, then how we will use practically, then it must be defined in that manner. It was a concrete example that quantum computer could solve certain type of a problem much more efficiently than the classical computer. So, this is very clear, just to factorize the data in a small unit and then it is processed by keeping the security in mind. Shor algorithm are used. Moreover, the algorithm spurred a new wave of research and development in the quantum computing. It triggered significant interest in the quantum algorithm that could solve other classically difficult problems, leading in development of the quantum computing models and technology. What is the mechanism and the process of the Shor algorithm? What is the mechanism? Shor algorithm seamlessly integrates quantum and classical computing processes. Means we are using the classical as well as the quantum, and then in the hybrid manner or integrated manner, this algorithm is used. What is the mechanism? First, the random number selection. Start by choosing a random number. It may be A that is co-prime with the target number n. Means we are having a n number, target n number, then randomly choose an A number. So, co-primality is verified by ensuring the greatest common divisor of A and n is 1. So, next is the quantum period finding. That is also the one of the important mechanism. They employ a quantum period finding algorithm to determine the period r of the function that is defined as fx. Now, this involves the construction of the quantum circuit and modular exponentiation and applications of the quantum Fourier transform. Means in hybrid manner we can use Shor as well as the quantum Fourier transform, that is the QFT. Now, another is the impact and applications of the Shor algorithm. Shor algorithm remarkably ability to rapidly factor numbers has significantly consequences for the RSA encryption and cyber security. Another, this is intensively used in the research into developing the quantum resistance cryptographic techniques, fundamentally reshaping the landscape of the digital security. So, its efficiency also opens the door for advancement in the field where factorization plays a key role, such as computational number theory and advanced algorithm research. Shor algorithm consists of the two important parts. First is the classical reduction, as we are talking about, that it is reducing, factorizing. So, it is the classical reduction. Another is the quantum algorithm to solve the order finding problem. Means whenever we factorize it, then we give the some number to them, and then these number can be solved by the ordering finding address. Means whenever we factorize, then we give the some address to the particular factorized units, and then these units can be solved by order finding problem. So, Shor algorithm consists of the two parts. First is the classical reduction, second is the order finding problem. In the classical reduction, a complete factoring algorithm is possible if we are able to efficiently factor arbitrary into just a two integers, maybe p and q greater than the 1. So, since if either p or q are not prime, then the factoring algorithm can be run on those until only the prime remains. So, it will run on the primes. So, for prime powers, efficient classical factorization algorithm exists. Hence, the rest of the quantum algorithm may assume that it is not a prime power. So, another is the quantum algorithm for the order finding. So, that we will define by establishing the factoring which is less than that of the order finding. So, we showed that if we could somehow find the order, we could then classically factorize the m. So, now we shall see how one actually find the order. Now, we are having a n bit integer a and m. Let n is defined as 2 power polynomial n greater than m, where the polynomial n is something ridiculously large as compared to the n power 10. Such number n can still be written by the poly n bits. So, this algorithm contains the two step. First step, where we use the quantum phased estimation with the unitary, that is defined by the u, representing the operation of the multiplying by a modulus n. So, input state where the second register is made from a n qubit. So, the eigenvalue of this u encode information about the period and can be seen to be writable as a sum of its eigenvectors. So, this quantum phase estimation stage gives as the output a random integer of the form for the random. Another, the point 2 is the use the continued fractions algorithm to extract the period from the measurement outcome obtained in the previous stage. So, this procedure to post process the measurement data obtained from measuring the output quantum state and retrieve the period. First, the output we can get in the form of the quantum state, and after that these are extract in the period form. So, number 1, factoring, that must be less than equal to order finding. So, factoring reduces a order finding. Factoring reduces the order finding, which means that if we have a algorithm to solve the order finding efficiently, we can efficiently solve the factoring problem as well as by a polynomial time reduction from factoring to the order finding. Means whenever we use factoring reduces the order finding. Note that this reduction can be made classically, but in the form of the quantum, that is the another form where we identify the simple fraction. So, but in the second step, order finding means period, finding the order, that is approximately the same problem as the period finding for the quantum computer. So, this will be expanded. This can be expanded by solving the various mathematical equation or by the algorithm. So, third step, where identify the simple fraction. The part is necessary in a order finding algorithm, that is crucial for the Shor algorithm. So, now the Shor algorithm is the key step in the identifying the simple fraction. So, in mathematical terms, we can have by using this by example, as we use it the Grover to solve the problem. So, this algorithm can be solved by using the various. So, example if we take, then the problem is finding a specific card in a shuffle deck of the n cards. So, classically this can be done by searching the deck of the cards one by one, but in case of the you can say in this algorithm we are having a n step, we not need the n step, but the n evaluations of the oracle representing the inspection of the card. So, we can use the Grover algorithm for the evaluation of this series. So, that the probability of finding the right answer is not in 100%. So, we become clear from the step in the algorithm. Other example where the Grover algorithm for the similar method are used for intense minimization problem. So, we can solve the hard problem in a very simple manner. So, what are the steps of this algorithm, where first the initialization of the qubits, number 2 execution of the oracle, the system that we are having, third is application, diffuse operation, fourth is repetition, fifth is the final measurement. So, these are the various steps. So, oracle function is followed by the Grover algorithm. So, this algorithm can be used to solve the complicated problem into a very simple problem. Another type of the algorithm is the quantum Fourier transform algorithm, and this is one of the quantum algorithm that performs the discrete Fourier transform on a amplitude of the quantum state, acting as a unitary operator. So, DFT is used just to solve the discrete quantum transform. So, it is an quantum analog of the classical discrete Fourier transform, that is a DFT. a crucial component in many quantum algorithms like Shor algorithm and the quantum phase estimation. So, QFT leverages superposition to a process all possible inputs simultaneously, enabling exponential speedup over the classical algorithm. It will solve the many problems, many in all the possible inputs simultaneously can be solved by the QFT, not one by one, by enabling the exponential speedup over the classical algorithm. For certain problems, by converting the phased information into a measurable frequency, converting the phase information into a measurable frequency. So, QFT is a quantum analog of the classical discrete Fourier transform. It operates a quantum state transforming a set of amplitude into a frequency. Just it transforms the set of amplitude into the frequency. In frequency domain representation of the mathematically, it applies a specific unitary transformation to the qubits, mapping a state to a superposition of the states weighing by the complex roots of unity. So, we can transform the specific unitary to the qubits in the quantum Fourier transformation. Unlike the classical fast Fourier transform, that is a FT, which processes the data sequentially. So, but this QFT act on all the amplitude in the parallel by leveraging the quantum superposition. That is why we use superposition in the quantum technology. So, in quantum technology, when we solve the any equation which is all the amplitude in the parallel by leveraging the quantum superposition. So, its circuit implementation uses a sequence of Hadamard gates and controlled phase rotations with a structure that scales the quadrically in the number of qubits, that is O n power 2 gates for the n qubits. This efficiency is key to its role in the quantum algorithm. Fourier transform speed up quantum algorithm by enabling efficient analysis of periodic or structured data. So, for example, Shor factoring algorithm uses QFT to identify the period of a function. So, in a hybrid manner, the Shor algorithm can use the QFT, a step critical for breaking down large number into the primes, and it is used efficiently. So, classically finding such periods requires checking the exponentially many values, but QFT allows quantum states to interfere constructively, amplifying the correct periods signal. So, by using the superposition, QFT done these in a very fast manner. So, the QFT ability to process all the possible states simultaneously. That is why we define it as a superposition that extract the global pattern by interference, reduces the computational step from the exponential to the polynomial. So, this is possible because QFT avoids explicitly iterating through all the inputs, instant transforming the state in a way that collapses measurement into the useful information. So, this will be used in the form of the by the superposition, and the useful information we can get through the just to iterating, not iterating all the inputs, but it transforming the state in a way that it will just collapses the measurement into useful information. So, concrete example is the Shor algorithm, where QFT is applied after a modular exponentiation step. So, the QFT converts the accumulated phase information into a measurable frequency, revealing the function's period. In the Shor algorithm, the QFT is applied for measuring the frequency in the form of the useful information, as well as just it revealing the functions period. So similarly, quantum phase estimation is subroutine in the many algorithm relies on QFT to determine the eigenvalues of the quantum operator. So this application exploit QFT ability to handle the large database encoded in the quantum state with minimal operation. That's why all the data is in the form of the superposition state, and that we will use. So QFT ability to handle the large data sets encoded in the quantum state with minimal operation. So while classical requires ON log n operation for the n data points, QFT operates on n qubits. Encoding n is equal to 2 power n values with O n square gates, making it exponentially faster for problems that of the fit this structure. So this efficiency is done by the QFT. So many unrips many quantum speed up through it's not universally applicable. So it excels where periodicity or the phase relationship are central. So QFT is used. So this is the QFT, and this QFT used through the Shor algorithm. Now another algorithm is the Grover algorithm. That is one of the most important algorithm in the quantum computing for retrieval of the data from the large number of the data set. As we know, the data set is growing day by day. So how we retrieve the exact and efficient data? So by using this Grover algorithm, as we are doing the computation on the quantum technology, so to make this quantum search in an efficient manner or in a faster manner, so the Grover algorithm is used. So in 1996, Love Grover introduced an algorithm that significantly accelerated the potential of quantum computing in searching task in a efficient manner. So Grover algorithm is renowned for its ability to search through unsorted database quantically faster than any classical counterparts. Means whenever we are having unstructured data, so this unstructured database can be have the data in a random manner. So by using this Grover algorithm, the data can be searched in a random manner from the random data or the unstructured data in a efficient manner or in a faster manner as compared to the classical algorithm, showing a substantial quantum advantage in the search related operation. So in the search related operation, Grover algorithm is used. So what it does? So Grover algorithm searches through unsorted database or solution spaces with a quadratic speed up over the classical method. So requiring only the O root n operation compared to the O n classical operation. So it is making the only the O root n operation for just to get the data from the large database. So to find a marked item among the n possibilities, so database can be retrieved through the O root power n operation and the classically used O n. So by using this, the data retrieval can be faster. Another is the when the Grover algorithm makes a difference for the searching problem. So it is very clear that the Shor algorithm we use for the factoring, and the second we are using the Grover algorithm that is used for the retrieval. Both used in the large data set. QFT, that QFT used for the period description. So, further we will discuss the Grover algorithm, how we use the Grover algorithm, what are the application of the Grover algorithm, we will discuss further in the next lecture. Thank you very much.